right, welcome everyone to tonight's Tech Talk. I have the immense pleasure to introduce you to our hosts, Ozar English and Timeo Williams, who are presenting to us scaling databases. Before we start, let's unmute ourselves and give them a big round of applause.
Yeah.
Good evening. Thank you, guys. We want to start by thanking SingleSprout for sponsoring this Tech Talk. Today, me and Asar will be talking about scaling databases. So, scaling databases. Before we get started, let's talk about a quick business use case, and this is where this development. So, Plenty of Fish is an online dating company that it was started off as a very simple college project that expanded to $1 million to $1 billion user web thing. And that transition from 1 million to 1 billion visitors involved a lot of growth. And to handle that growth required database scaling. You know, it was a freemium model, which means to cover those costs was difficult. The CEO, Marcus Flynn, mentioned that the problem with free is that every time you double the size of your database, the cost of maintaining the site goes 6 times. So, the question we want to answer is, how do you manage that transition? The solution is scaling both in a hardware paradigm and a software paradigm. I'm going to pass it to Asar to talk about that.
Thanks, Tim. So one method of handling demands of ever increasing requests on your system is through vertical scaling. It essentially involves increasing the resources of your server, whether that's through your RAM, your CPU, or your GPU, and or other resources. It's known as scaling up. I mean, I like to think of it like renovating your apartment. Now, imagine you're someone who really likes real estate. You currently live in a nice apartment, in a skyscraper, but you want to add to your real estate portfolio. I mean, so you could go out and find an apartment in a whole new building and have to deal with the inconvenience of moving and refurbishing a whole new place. But instead, you just think, hey, I'll just buy the unit above me and now I have a duplex. Well, that's essentially scaling up. It's basically when you realize your system is getting slow and unable to handle the current number of requests, then you realize you need to scale it up and you use vertical scaling. Now, vertical scaling has many pros and cons, which I will illustrate for you in the next slide. So as for the pros, it's very easy to implement. It's especially in the cloud environment. It consumes less power because you're only running a single server versus running multiple servers. And it means less admin effort since you need to handle and manage just one system. Now, there are also cons, and some of the cons include the fact that it can be expensive, as costs generally associated with replacing a machine with a more performant machine generally increase exponentially. Also, vertical scaling represents a single point of failure. After all, if you have a single machine, if that machine fails, then your entire system will fail. Vertical scaling also involves more downtime since increasing resources on your server requires a restart for your system. And that means that your system, chances are your system will be put down for extended periods of time.
Awesome. Let's go into horizontal scaling. And horizontal scaling, taking Asar's apt analogy of that New York City skyscraper in downtown Manhattan. Horizontal scaling is more along lines of everyday people. I can't afford that, but maybe I could afford a middle class suburban home. And if one of those homes were to go down, they were to have a fire, the cost of replacing that is much more bearable. So there are pros and cons with horizontal scaling as well. It's the strength in numbers, the fault tolerance of handling. If one of those houses went down with a fire, a server went down because there's too much network traffic hitting it. Well, you have a bunch of other servers on standby, ready to handle that traffic. It's more cost effective. The horizontal scaling strategy is under the premise that you're buying mid-tier servers. So it's not as expensive as that one tall skyscraper. But the cons are that licensing. Assuming you don't operate under an open source model, you're paying license fees to Microsoft SQL, to Oracle database to handle for every single server you have in that strategy. There's also increased utility costs and an increased carbon footprint. So the question is, what do you choose? Do you choose vertical or horizontal? If I gave you $100,000 as a business and you had to choose between those two options, with a vertical scaling strategy, you just put the bulk of that money into one one top tier server. In a horizontal strategy, that $100,000 can get you about 83 mid-tier servers. Performance metrics. So you look at it right now, it looks like horizontal has you beat. That many servers, a lot more gigabyte RAM, CPU. The issue comes with licensing costs and utility costs. So let's talk about licensing. So you may say to me, Tomeo, if I were to do an open source licensing paradigm, I would not pay money for that. And the issue comes with open source that, we looked through some threads. You have to employ developers to handle that open source network, as opposed to calling Microsoft up to handle those issues. So everything has its pros and cons. I'm going to pass it to Asar to talk about the software side of databases.
Thanks, Tim. So in terms of the software side of databasing, there is a really effective method of horizontal scaling known as sharding, which basically involves splitting data among several nodes. So say, for example, let's say you have a pizza and you can't eat the entire pizza by yourself. I mean, if it was just me, I'd have the entire pizza by myself, but whatever, I digress. So you break into slices and you share it with each of your friends. Well, essentially that's sharding. Think of it as you being the database, the requests that are being fielded to you are the pizza, and each friend you share a slice with is basically a sharding server. So sharding makes a very useful strategy in situations where the amount of application data exceeds storage capacity of a single node, or when the volumes of reads or writes to a database exceeds what the database or the node holding the database can handle. Now, I'll walk you through a simple demo that shows the process of sharding. All right, for the sake of time, we set up a cluster in MongoDB, which we've containerized in Docker. And now we're just gonna run some terminal commands showing an simple example of sharding using 2 nodes in MongoDB cluster, and each node will house a single shard. So the first command that I'm going to run is going to run the first node that's going to hold our first shard. And then I'm going to run another command to run the node for our shard 2. All right, and so we have 2 nodes up and running. First shard is running on port 2718. Second is on port 2719. And now that the nodes are launched, we're going to configure our sharding cluster. So I'm going to put in a command to do that. And if you take a closer look at the terminal, you can see that we now have 2 shards. The first shard is shard 000, and the second is shard 0001. All right, so now for the exciting stuff, we are going to now run a command that adds a document to our collection. And essentially what we're going to see is we're going to see where does this document, which shard does this document show up on? Does it show up on shard 1 or does it show up on shard 2? Can't wait. All right, let's see what we have. Oh, so it looks like it's shown up on shard 000. Yeah, fun stuff. So what's interesting about this is we only have 2 shards, but essentially every time you add a document, there's an upper limit of data that each node that's holding a shard can handle. So if that data, that limit is exceeded, then every subsequent document added to the collection will then be added to a subsequent shard. And since we're only working with limited data set, we're going to keep on adding documents, and they're going to show up on shard 000. All right, well, that's basically a simple walkthrough of sharding in real life. And now we're going to do is I'm going to hand the floor back to Mayo to talk about the various data management systems and their various preferences, either towards vertical scaling or horizontal scaling.
Thank you, sir. Here you have 3 photos of 3 different database managed systems, all using NoSQL. And in particular, I want to go into focus on one of them called Cassandra, Apache Cassandra. Apache Cassandra is a NoSQL open source database management system that employs horizontal scaling in its paradigm. And as opposed to doing sharding, which just talked about, one common method is replication. So Cassandra is known for being very, very durable. And how it does that is the users will set into the terminal the RF factor, the replication factor, by which we won't have a copy per se of every node, but a set of nodes will be replicated. And with that, Cassandra can manage to have really durable, long-lasting databases. In summary, we've talked about a lot of stuff, vertical and horizontal scaling being those 2 solutions for handling growing databases, and sharding being a very effective and popular tool for maintaining scalability. If you're interested in looking to some more details about this stuff, check out the links in that slide. And if you have questions for us, me or Asar, feel free to just send us an email and ask us in GitHub. And that is it. Thank you. And if you have any questions, please bring it to us.
All right, before we open up the floor for questions, let's give them another big round of applause.
Yeah.
Awesome, Kyle.
Yes, you mentioned that in vertical scaling, it has a lower carbon footprint. I'm curious as to why that would be, because I don't know.
100%. I saw my table this one. So it is, when we speak about these slides, we're speaking in generalities. So vertical scaling traditionally does have lower carbon footprint, but it's also because you're making an assumption. You're making an assumption that it's a smaller company and that it's only handling a set amount of network traffic. And if it's under that premise, yes, you have one standalone server at your design facility that's taking just a very limited scope of real estate. So as opposed to a horizontal scaling paradigm, where you have multiple servers out in a very large landscape, and then the energy costs to wire up, to route all these individual servers, it does cost and it does add up. Now, granted, if that vertical server happened to be top of line specs, as opposed to 3 very, very, very low spec servers, yes. But in generalities, vertical scaling does have a lower carbon footprint.
Great, thank you.
Great, Brian?
Yeah, when would vertical scaling be preferred over horizontal scaling?
I can take this question, Tim. So generally speaking, horizontal scaling is preferred method, but there are a few situations where vertical scaling would be preferred. And one of them would be, say, the cost of, upgrading your existing server, which you're basically scaling up, is cheaper than adding new computers to your network. And then another situation would be, say you needed to, say the amount of OS subscriptions for the nodes that you wanted to add to your system. Say you didn't have enough subscriptions for each node. Well, then it would be prohibitively expensive then. So then instead of buying extra subscriptions, which let me tell you, they're very expensive. It would be more cost effective than just to scale vertically and only work with a single machine. But generally speaking, horizontal scaling is preferred overall because it's just more highly available and because of its elasticity.
I just want to add on to that. If you're a small business owner and you're just starting off, you're not sure how much scope this particular business is going to grow, you could just have a standalone server. It has single point of failure. It has all those downsides, but for the sake of getting your leg up, that's also fine. I mean, the preferred solution would be utilizing microservices, AWS microservices. That's a really good starting solution. But if that wasn't available, then that would be vertical scaling.
Thanks, guys.
No problem.
Awesome. No more questions. Let's give them another round of applause. It was great answers. Right, that will be all for today. Thank you all for coming.